Alright, a very good day to you here, 9 students, secondary students. For this particular chapter, we're going to look into the calculations of binary number systems. Binary numbers actually uses a system called the base 2 numbers. And later in this video, we will talk a little bit about what is base 2 later on. Now, in our real world calculations, like 10 plus 2, 100 plus 15, 415, add up a number of numbers, all those numbers are called the base 10 numbers. And why do we call this the base 10 numbers? Because the base 10 numbers have 0 to 9 numbers. We use these numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, if you take all these numbers together and you jumble up together, let's say for example, I want to add up 30 plus 4. And I can actually just take up the tree and then put the tree right here. And then I take that 0 and arrange that here. And then I add and put that number over there. And then when these numbers added up together, 34, it's literally putting all these numbers together and rearranged it using the base 10 numbers. And that's exactly how our real world calculation is. We use a base 10, we use 10 different digit numbers to make sense of our world in a mathematic way. But in the computer systems, like again, we use the base 2 numbers. In computer science, we use these two numbers, which is the zeros and ones. And this can be represented as a light bulb. One, that means there is information, and you can imagine this being a light bulb, lights it up. And zeros can be imagined as there's no light bulb, there's no information. So how do we actually use the base 2 system to calculate the binary system? Because binaries are combinations of ones and zero. So right here, let's take an example of the 8-bit system. Now the 8-bit system, that means that we have 8 ones and zeros. So probably 0, 0, 1, 1, 1, 1, 0, 0. And that's a 8-bit binary. But in that 8-bit binary, there is a certain information that the computer actually stores. And we're going to find out what it is actually. So to do that, we have to use the base 2 mathematics system. And what is the base 2 mathematics system is pretty simple. Now, base 2 is actually a calculations of this. So we're going to take the first number and put it on the right. And then we're going to try to imagine there is a table. And then we're going to multiply this by 2, and then multiply it again. 4 will be 8, and then 8 will be 16, and 16 will be 32, and then 64, and finally we have 1, 2, 8. All right. So if you just imagine this visually, I'm just going to just draw this out. It's going to multiply by 2, 2, and 2. And that it's 1, 2, 4, 8, 16, 32, 64, and 1, 2, 8. Now I'm going to rewrite this again to look nicer so that we can have a little bit of calculation later on. Once again, from the right to the left, 1, 2, 8, 1, 2, 4, 8, 16, 32, 64, and then 128. Now remember, just now right at the top, we have the bit number 0, 0, 1, 1, 1, 0, 0. Now, I'm going to try to rewrite them under the numbers that I just made. So 0, 0, 1, 1, 1, 1, 0, 0. Okay, I'm going to try to use another color to visualize this into individual columns and rows. Now, as you can see that the numbers are being arranged and then placed into a column, and then to find out what does this bit actually means right at the top here, okay, what this 8-bit 0011 1100 actually means in terms of binary, we're going to do a little bit of calculation. As you can see here, 0, 0, there's no information. That means we don't have to combine the 128 and 64. But at the 32 column, there is 1. That means we're going to take 1, and then you guess it right, you probably have to take 16 as well. So 16 plus 8 plus 4. And we don't have to take the 2 and the 1s all together. When you combine them and do the calculation, 32 plus 16 will be 48. And then you add it up together, 48 plus 4 plus, 48 plus 8 and plus 4. That will be 56. And then this will be a total of 60. All right, so the 00111100 in 8-bit, its total is 60. All right, we're going to try another calculation. And this time, of course, you have to, always when you do the binary conversion, you have to do the 1, 2, 4, 8, 16, 32, 64, and 128 altogether. And let's say we're going to calculate the number bit of 1110, 0, 0, 0, and 1. Now, if you are a beginner of this, one more time, you can always put the numbers of the bit right under the table for the numbers that we have just arranged. And if you would like to make it look good and focus on the numbers, you can definitely put it with the columns and the rows for all of these so that you can have a visualized table. And what you have to do immediately after you have the visualization of your table, you bring all the numbers that have 1s under it. So right here from the left to the right, 128 has 1, and then 64, and then 32. 16, 8, 4, and 2 does not have the value, so we're going to ignore that, and we're going to put the 1s right there. All right, let's do a little bit of a calculation. 128 plus 64 would be, my mental math is not very good, so we're going to take a little bit of time to calculate this. So 2, 6, 8, 192 plus together. And then we have 192 plus 32 plus 1. So this will be 4. And this will be 224. And plus 1 together, we have 225. And that will be the value of 11100001 over in this binary bits of 8-bit. All right. Now, shall we do one more practice so that you can get the hang of the calculations for binary conversion? All right, let's see. We're going to just draw out the table again with 1, 2, 4, 8, 16, 32, 64, 128. Now, let's use a different bit this time. And I'm going to write the numbers directly inside or under the table of the numbers right here. So this time we're going to take probably 0, 0, 0, and then we're going to have 1, 1, 1, 1. Now this time I'm not going to do the table so that we can do things a little bit faster. So again, with the numbers that has 1, so take it down. That is 8. 4 plus 2, and then 1 right up here, and you add all numbers all together, this will be 15. All right. Now, I hope that this video helps you, and you should be able to calculate the binary numbers using the base 2 systems. Good luck.